Alright everyone, welcome to Lesson 6.1, Simplifying Radicals, and we're going to dive into Video 1. So a couple vocabulary terms here that we need to pay attention to. That's the radical and the radicand, or you might hear it be called the radicand. So the next set of tools that we will add to our tool belt is simplifying radicals. To simplify a radical, we must first break down the radicand, or the number under the radical. So this example right here will kind of explain that. The number 72 is inside this radical, or under this radical, and we call this the radicand. So step one is to complete a fact tree for the radicand. Now, one thing that I like to do is think of what numbers will divide into this that would give me a perfect square. And the tool that I like to use for this is actually the table function in the calculator. Now some of y'all are probably thinking, oh, it looks like I could divide 72 by 2 and that'll give me 36. And that's great, and that is a perfect square. But I can also use the table function and plug in 72 divided by x, and when I start at 1, it will give me all of those factors of 72. And if you come across a decimal, it's not a factor. But it's an easy way to break down a number into its prime factors. So 2 and 36 is what I'm going to put here. So this breaks down to 2 times 36. And I'll cross out 72 because I know that 2 times 36 is 72. And the reason I like having 36 here is I know 36 breaks down into 6 times 6. And that's a perfect square. So what's great about that is that now I know that the square root of 36 is 6, or I have a pair of 6's, and I can pull that outside of my radical. Okay, so that's going to lead us into step 2. So identify those pairs, which is what we did. And under the radical, separate the radicand into the square factor and the non-square factor. So really what you can do at this step here is rewrite this as the square root of 6 times 6, the square factor, and then times the root of 2, which is what we have here. In other words, if I do 6 times 6 times 2, that's going to give me 72. You could also write it like this, 6 times 6 times 2, and then see here that I have a pair of 6's, and the 2 is left over on the inside. Okay, and then step 4 is to pull the perfect squares out, and that is what we did here. We pulled the perfect squares out to get our final answer of 6 on the root of 2. Let's look at another example. So here we have 5 on the root of 100x to the third. Now 100 is a perfect square, so I'm going to rewrite this as 5 on the root of 10 times 10 times x times x times x. And think about why I wrote x times x times x, because that's x to the third. And now I'm just looking for pairs because we're taking the square root. So I have a pair of 10's, and I also have a pair of x's. And what's left over is this x that's going to stay all by itself on the inside of the radical. So I'm going to pull a 10 out, so 1 10 for every pair, and 1 x for every pair of x's. So I already have a 5 on the outside. So I'll write the 10 that I pulled out, so that's this 10 here, and then the x that I pulled out, so that's this x here, on the root of this x that's left on the inside. So the square root of x times x is just x. The square root of 10 times 10, or the square root of 100, is 10. And then you have to simplify. So 5 times 10 is 50, and bring the x down, and you're left with x. So you have a couple U tries on the next page, so if you would try those, and then I'll see you in the next video.